Hi students, in this video I'll be going through the 2015 O-Level Mathematics Paper 1 question 14. Alright, so this is a question regarding prime factorization as well as HCF and LCM. Okay, so let's read the question. So in part A, they want us to express 450 as a product of its prime factors. Okay, so usually what I'll do is I'll just break down 450 into smaller and smaller numbers until they are all prime factors. Okay, so for 450, I'll break it down into something like 9 times 50. Okay, because this is rather obvious. Okay, so 9 we know that it can be broken down into 3 square, but I'll do that later. Okay, for 50, we can break it further down into 25, 2 times 25. Okay, so from here we can clearly see that after one more step, we will be able to get all prime factors ready. So because 9 is 3 square, okay, 2 is just 2, and 25 will be 5 square. Okay, so I like to write ascending order, so the final answer will be 2 times 3 square times 5 square. Right, so this would be the answer. Okay, then the next part, okay, find two numbers. Okay, so the problem given to us is that we are asked to find two numbers which are both smaller than 100. They have a lowest common multiple of 450, so lowest common multiple LCM, and highest common factor of 15. Okay, so in this question, we are asked to find two numbers. Okay, so first number and second number, right? Two numbers. Okay, and the LCM is 450. Okay, we have already broken down 450 into this, right? Okay, so I'll put this instead because we need to make use of that to solve the question. So 2 times 3 square times 5 square. Okay, the HCF is 15, so 15 is just 3 times 5. Okay, also broken down into prime factors. Okay, before we do this question, I would like to do some recap first. Okay, so recap. Okay, so let's say we have two numbers. The first number, let's say in prime factorized form is 2 square times 5 times 7 cube. Okay, and then the second number, if let's say is 5 square times 7 square, right? Okay, so now if we want to find the LCM, okay, basically for LCM, we will just look at each individual prime factor, and then we will take the one with the bigger power. Okay, so over here we have 2 square, okay, 2 square, but down here doesn't have a 2. If you don't have a 2 means it's 2 power 0, okay, which will become 1 instead. Okay, so LCM we want a higher power, so since the second number doesn't have a 2 as a prime factor, then we will take the higher power, which is 2 square. Okay, then for 5 and 5 square, the top one is 5 power 1. Second number is 5 power 2. So we will take the bigger one. So we get 5 square. Okay, then for the third one, 7 cube and 7 square, we will take 7 cube. Okay, so for LCM, you will take the higher power. Okay, for each prime factor, when you compare the two numbers. Okay, then how about for HCF? Okay, so for HCF, we will take the opposite instead, take the smaller power. So the first one has 2 square, the second one doesn't have 2 square, so there will be no 2 as a prime factor for the HCF. Okay, the next one, 5, let's look at 5. 5 and 5 square, we will take the smaller, so we'll take 5. And then 7 cube and 7 square, so we will take the smaller one. So this one will be the HCF. Okay, so let's try to apply this logic to help us to solve the question. Okay, okay, so let's say okay, let's compare the two first. Okay, the LCM has a 2, the HCF has no 2. Okay, so this simply implies that one of the numbers must have a 2, the other one doesn't have a 2. Okay, has no 2. Okay, so I won't write it, okay, because there's no 2, okay? Right? Okay, then the next one, let's look at the 3, okay? So we have 3 square and 3. Okay, so we are wondering where do we put the 3 square? Do we put it to the first number or to the second number? Okay, so let's since the first number already has a 2, let's maybe put a 3. Because remember, we need both to be smaller than 100, right? Then we put the 3 square here. Okay, then the next one, first number and second number, let's look at the 5. So one must have 5 square, the other will have 5, right? Okay, so let's try to put the 5 square here. Then we will have 9 times 25, which will obviously be more than 100. Okay, so we say that the 5 square cannot be here. Okay, so how about we put the 5 square over here? Okay, so if you put the 5 square over here, you will see that you will have 2 times 5 square, which will give us 50. 50 times 3, also cannot. So there's no place to put the 5 square. Okay, so this means that we may have to make some adjustment over here, right? So this one doesn't work. Okay, this one doesn't work. Okay, because of the 5 square, no matter where you put it, top or bottom, it's going to be more than 100. Okay, more than 100, so it doesn't work. Okay, so we will disregard this first set of solution over here. Okay, let's find the first number and second number. Okay, below over here. So first number and second number. Okay, so one must have a 2, the other one has no 2. Okay, so this one is quite obvious. Okay, so remember just now we put the 3 square on top. Why not we try to put the 3 on top instead and the 3 square below? Okay, and then we see whether we will be able to fit in the 5 square or not. Okay, so just now we put the 3 on top, right? Okay, so let's put the 3 square on top. Okay, I was looking at this. Okay, just now we put the 3 on top. Okay, so now we will put the 3 square on top and the 3 below instead. Okay, so let's see whether this will help us. Okay, so now we need to put the 5 square and 5, right? So one of the numbers must have the 5 square, the other one must have the 5. Okay, so let's try the 5 square over here. Okay, obviously we can't put 5 square on top. 3 square is 9, 9 times 25 square, 25 is going to be more than 100, okay? Okay, let's see whether this will work. Okay, 3 times 5 square, 3 times 25 are 75. It's okay, less than 100. Okay, 2 times 5, 10. 10 times 3 square, 9, so equals to 90. So this combination will work. Okay, so this combination will work. Okay, so find the two numbers. So in other words, the two numbers would be 90 and 75. Right, so this is how you analyze a question like this. Okay, so it's just like some sort of like playing a game like that. Okay, so do try. Okay, and there are some similar questions in the PYS. Okay, to this. But if you practice more, then you will be more confident. Right.